I'm Thomas Aslan Ballas, and this is an explanation of Sirius, the Steganographic Relay System. To begin, we have a problem. People want to send messages, but the content of these messages might get them in trouble. And the usual solution, encryption, generally earns the message and its author higher scrutiny. To look at this visually, for those of you familiar with cryptography, you might recognize Alice, Bob, and Eve. To rehash the old scenario, Bob is trying to send a message to Alice. Eve has access to the communication channels and can monitor anything that's sent back and forth. This is usually where encryption saves the day. But let's change the problem. Here, Eve is a state actor, and at her disposal, she has a large, highly skilled body of encryption breakers. If Bob attempts to send an encrypted message to Alice, Eve will get suspicious. She'll flag the message for decryption, and if he's lucky, will put Bob in a dark pit for the rest of his life. In the end, Eve gets the secret message, Alice gets nothing, and Bob is in an unfortunate situation. So we opt for something less conspicuous than encryption. Instead, we use steganography with an encrypted message. This way, Eve doesn't flag the transmission for being suspicious, Alice can easily extract and decrypt the secret message, and Bob stays out of the labor camps. To paraphrase what Wikipedia has to offer, steganography is the practice of hiding a message in a manner that doesn't arouse any outsider suspicion of its existence. Here, we have the technical diagram of a steganographic system. On the left side of our function, we have a cover, C. That's the medium in which the message will be hidden. This cover has a property F. That is the space in which we can hide our message. Associated with C and F is SC, our steganographic algorithm. This is how we use F to hide a message. Then we have our message M. We plug C and M into our embedding algorithm E. And we're given C hat, our new message containing cover. In more practical and much simpler terms, I have a cover, in this case the image of a cat. Then I have my message, which in this case is my resume. The picture of a cat is, in data terms, an array of 4-byte pixels. So the F of this cover is the very last bit of that 4-byte string. SC is then changing that last bit to correspond with my message. This alteration will change the 32-bit integer value of each pixel by at most 1. So the change is imperceptible. I will read each bit of every byte in my message into the last bit of each pixel sequentially. This is my embedding function E. At the end I have C hat, which in this case is the image of a cat with imperceptible alterations. Returning to our old example, Bob sends a stego message. Eve sees the picture of a cat and decides it's not suspicious. She decides not to waste her resources on analyzing the cat and lets it go through. Alice receives the image, extracts the message, and then decrypts it. Bob remains happily out of prison. So we take this idea and make something usable. The goal is to make steganography available to everyone, a system where message senders don't have to worry about middleman onlookers. Doing a quick market analysis, there are a couple of products that have tried to do this. There's StegHide, StegGUI, the GUI cover of StegHide, Silent Eye, Steganography application, and unlisted here, OpenPuff. The majority of these are outdated by several years. Additionally, they all perform steganography using the simple algorithm I described earlier. The issue with that is that it becomes susceptible to data corruption via compression algorithms. And at least in the case of steganography application, simply don't work. So we'll make something better. We'll make Sirius. It uses a ubiquitous base, mobile phones. When a user wants to send a stego message, they open the app and type away. When complete, they're instructed to take a few photos, and the application embeds the encrypted message before uploading it to a social networking or image sharing website. From there, our server takes over. It downloads and decrypts the message before posting it to our online broadcasting site. and this way the app user has sent their message and we've made it public, completely anonymous. Here we see the system topology. Beginning with our app, the Stego image is uploaded to a known website outside of our influence, perhaps Facebook, Flickr, Imager, what have you. We then download and decrypt the message before uploading it to our own website on the far right in plain text. As I've noted, the system is comprised of two main parts, the Android application and our backend server. The challenges that Sirius currently faces are the following. First, finding a Stego algorithm that is less susceptible to compression schemes. Second, integrating the discrete pieces, both those under our influence and not. Finally, determining an inconspicuous method of recording the user accounts of our applications.